In this video, we will do the problems from exercise 3.1. So the first question is, identify the quadrant in which an angle of each given measure lies. So the first is 25 degrees. So before we go into that, we know that this will be 0 degrees and also 360 degrees. And this is 90 degrees. And this is 180 degrees, and this is 270 degrees. So 25 degrees, the first one would fall in the first quadrant. This is the first quadrant. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So to answer the questions, number 1, 25 degrees will be in the first quadrant. Question number 2, 825 degrees. So if you take a full rotation, it's 360 degrees. Then 2 rotations will be 720 degrees. So 825, we subtract 825 minus 720, which is 2 rotations, you'll be left with 105 degrees. So your actual result will be 105 degrees, which will be in the second quadrant. So the answer is 825 degrees is in the second quadrant. Question number 3. This is minus 55 degrees. So we know that the measure goes in the anti-clockwise direction, the angle measure. So if you say minus 55 degrees, then you need to do it in the clockwise direction, so it will be in this manner. So minus 55 would be in the fourth quadrant. So minus 55 degrees is in the fourth quadrant. Then number 4 is 328 degrees. We know the full circle is a 360, and the third up to the third quadrant is 270 degrees. So 328 will fall on the fourth quadrant. So you say 328 degrees is in the fourth quadrant. Then the last question, which is number 5. So 100 minus 230 degrees. So minus would be again in the clockwise direction. So 230 degrees would be in the second quadrant. So minus 230 degrees is in the second quadrant. Question number 2. For each given angle, find a coterminal angle with measure of theta such that theta lies between 0 to 360 degrees. So let's look at the first one. The first one is 395 degrees. So 395 degrees minus 360 would be 35 degrees. Therefore, 35 degrees is a coterminal angle of 395 degrees. The second question, 525. So we know that 2 cycles will be 720. So if we subtract this 525 by 360, we should be able to get the angle. So that would be equal to 5, and that's a 6,
and 4 minus 3 will be 1. 165 degrees. Therefore, 165 degrees is a coterminal angle of 525 degrees. Then the third question, which is 1150 degrees. Now we know one full cycle is 360, second cycle will be, 2 cycles will be 720, and 3 cycles will be 720 plus 360 will be 1080. So if we subtract 1150 minus 1080 degrees, then your answer would be 770 degrees. Therefore, 70 degrees is a coterminal angle of 1150 degrees. Then the fourth one is minus 270 degrees. So when we say minus 270, it is in the clockwise direction. So minus 90 would be here, minus 180 would be here, minus 270 will be exactly the 90 degrees here. So 90 degrees is a coterminal angle of minus 270 degrees. Then the last one, which is minus 450 degrees. So when you say minus 450 degrees, it's in the anti-clockwise direction. So one full cycle in the, clockwise direction, one full cycle in the clockwise direction will be 360 degrees. Then 450 minus 360 would give us 450, or we can say plus 360 would be equal to minus 90 degrees. So minus 90 degrees would be exactly 270 degrees. Therefore, 270 degrees is a coterminal angle of minus 450 degrees. Question number 3. If A cos theta minus B sin theta is equal to C, show that A sin theta plus B cos theta is equal to plus or minus square root of A squared plus B squared minus C squared. I have put here the shortcut methods, or you can call it the tricks, to solve this question. So first you will have to square the given equation, which is this equation. You need to square it. So when you square it, A cos theta minus B sin theta squared will be equal to C squared. So further expanding this will be A squared cos squared theta plus B squared sin squared theta minus 2AB cos theta sin theta is equal to C squared. Next, step number 2. Replace cos squared theta by 1 minus sin squared theta and sin squared theta with 1 minus cos squared theta. So, replacing these two terms, this will be A squared into 1 minus sin squared theta plus B squared into 1 minus cos squared theta minus 2AB cos theta sin theta is equal to C squared. So further expanding this will be A squared minus A squared sin squared theta plus B squared minus B squared cos squared theta minus 2AB cos theta sin theta is equal to C squared. So if we rearrange this by moving A squared, B squared and C squared to one side and the remaining items to the other side, and we overall multiply both the sides with a minus, then you would end up with a squared sine squared theta plus b squared cos squared theta plus 2ab cos theta sine theta is equal to, we have taken a squared to the other side and we have changed the sign, so this will be plus a squared here plus b squared, and plus c squared will be minus c squared. Further, this is in the form a plus b the whole squared. So this is a sine theta plus b cos theta the whole squared is equal to a squared plus b squared minus c squared. Taking the root of both sides, you get a sine theta plus b cos theta is equal to plus or minus square root of a squared plus b squared minus c squared, which is our LHS equals RHS. Hence the proof.
Question number 4.
If sine theta plus cos theta is equal to m, show that cos to the power 6 theta plus sine to the power 6 theta is equal to 4 minus 3 into m squared minus 1 the whole squared divided by 4, where m squared is less than or equal to 2. So to solve this, the tricks that we would use is, first take m squared minus 1 and replace this m with sine theta plus cos theta. So our m squared minus 1 is equal to sine theta plus cos theta squared minus 1, which is equal to sine squared theta plus cos squared theta plus 2 sine theta cos theta minus 1. We know that our sine squared theta plus cos squared theta will be 1. So 1 minus 1 will be 0. So this is equal to, or I can say 1 plus 2 sine theta cos theta minus 1, which is 2 sine theta cos theta. Next, step number 2. Let's substitute this and do the square as this form here. So m squared minus 1 the whole squared will be equal to 2 squared, which is the square of this, which is 2 squared, which is 4 sine squared theta cos squared theta. Next, let's replace it in the RHS. So our RHS is equal to 4 minus 3 m squared minus 1 the whole squared divided by 4, which is equal to 4 minus 3 times 4 into sine squared theta cos squared theta. Sine squared theta cos squared theta divided by 4. If we take the 4 out, then we can cancel it with the denominator 4. So you will end up with 1 minus 3 sine squared theta cos squared theta. Now let's take the left hand side. So the LHS is cos to the power 6 theta plus sine to the power 6 theta. What we would do here is, as in step number 5, we will use this equation, which is a cube plus b cube is equal to a plus b into a squared plus b squared minus ab. So if we take our cos squared theta cube plus sine squared theta cube, then this can be further written as cos squared theta plus sine squared theta, which is a plus b here, then multiplied by a squared plus b squared minus ab. So our a here is cos squared theta, so square of that will be cos to the power 4 theta plus sine to the power 4 theta minus cos squared theta sine squared theta. So we know that this is equal to 1. Cos square theta plus sin square theta is equal to 1. Therefore, what we have is cos squared theta squared. If I take this cos to the power 4 as cos squared theta to the power 2 plus sin squared theta to the power 2 minus, we have cos squared theta sin squared theta. If I will add this with 2 cos squared theta sin squared theta and subtract it with 2 cos squared theta sin squared theta, then if I take this cos squared theta squared plus sin squared theta squared plus 2 cos squared sin squared theta, then this will become a plus b the whole square. So this is equal to cos squared theta plus sin squared theta the whole squared minus, then you're left with this term and this term. So it's minus 3 times cos squared theta sin squared theta. So which can be rearranged as cos squared theta plus sin squared theta is 1. So 1 squared. So 1 minus, rearranging this 3 times sin squared theta cos squared theta. So you can see that RHS is equal to LHS. So LHS is equal to RHS, hence the proof. Question number 5. If cos alpha divided by cos squared beta plus sin alpha by sin squared beta is equal to 1, prove that. We have two questions here. The first one is sin to the power alpha, 4 alpha plus sin to the power 4 beta is equal to 2 sin squared alpha sin squared beta. So let's solve the first question first. So the tricks that we will follow for this is, let's first move this sign into the other side. So you will get this, then cross multiply the numerator and denominator, then we'll replace cos squared with 1 minus sin squared theta, and when we rearrange we should get this. So let's follow our tricks. So let's say cos to the power 4 alpha divided by cos squared beta is equal to 1 minus sin to the power 4 alpha divided by sin squared beta. Then if we cross multiply this, we will get sin squared beta cos to the power 4 alpha is equal to, taking the LCM here, this will be, instead of 1, sin squared beta. So it will be sin squared beta cos squared beta from here minus, again cross multiplying this with the second term, sin to the power 4 alpha cos squared beta. Next, we said we will replace cos squared theta with 1 minus sin squared theta. So wherever we have cos squared theta, cos to the power 4, we will be replacing them all with sin squared, 1 minus sin squared theta. So this is further, this will be equal to sin squared beta into 1 minus sin squared alpha squared equals sin squared beta into 1 minus sin squared beta minus sin to the power 4 alpha into 1 minus sin squared beta, which is, if you expand this, it will be 1 plus sin to the power 4 alpha minus 2 sin squared alpha, and then multiplying with this we should get sin squared beta plus sin squared beta into sin to the power 4 alpha minus 2 times sin squared alpha sin squared beta equals, for the expanding this, you will get sine squared beta minus sine to the power 4 beta minus sine to the power 4 alpha plus sine squared beta sine to the power 4 alpha. Now we can see that this term and this term is equal, so we can cancel them out. Similarly, we have our sine squared beta and sine squared beta as common. We can cancel it. So we are left with 1, 2 and 3 terms, and they are in the with a negative sign. So if you minus them all, both left hand side and right hand side, you will get 2 sine squared alpha sine squared beta is equal to sine to the power 4 beta plus sine to the power 4 alpha. Rearranging this, you can say sine to the power 4 alpha plus sine to the power 4 beta is equal to 2 sine squared alpha sine squared beta, or LHS equals RHS, hence the proof. Question number 5. If cos to the power 4 alpha by cos squared beta plus sine to the power 4 alpha by sine squared beta is equal to 1, prove that. The first condition, we already proved this first condition. We have to prove the second condition here, which is cos to the power 4 beta divided by cos squared alpha plus sine to the power 4 beta by sine squared alpha is equal to 1. So to prove this, we are going to rearrange the first inference that we had by taking this to the left hand side and making it to equal to 0, then taking the square of this, or expressing it as a square. We will be able to prove that sine squared alpha is equal to sine squared beta, then replacing this with 1 minus and 1 minus on both left hand side and right hand side. This will become cos squared alpha is equal to cos squared beta. Then substituting these values in the given equation here, you will get our result. So let's proceed. So we have here sine to the power 4 alpha plus sine to the power 4 beta minus 2 times sine squared alpha sine squared beta is equal to 0. So if we take the square of this, it will be sine squared alpha minus sine squared beta, the whole squared is equal to 0. So taking the square root on both left hand side and right hand side, you get sine squared alpha minus sine squared beta is equal to 0. That means our sine squared alpha is equal to sine squared beta. This is the first one. Then putting minus 1 on both left hand side and right hand side, you get this as 1 minus sine squared alpha is equal to 1 minus sine squared beta, which is nothing but cos squared alpha is equal to cos squared beta. This is number 2. Now LHS is equal to cos to the power 4 beta over cos squared alpha plus sine to the power 4 beta by sine squared alpha. Replacing sine squared with alpha with sine squared beta and cos squared alpha with cos squared beta, we can say that the numerator here is cos squared alpha squared by cos squared alpha plus, similarly for the sine squared beta, the whole squared divided by alpha here, sine squared alpha. We can further simplify this as cos squared alpha plus sin squared alpha, which is equal to 1. Therefore, LHS equals RHS.
Thank you for watching Maths Tutorial Anand. Please like and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.